Hi, welcome to another video on Raspberry Pi 1 with pulse width modulation on some electronics. And last two episodes I did the same as I'm doing now, a simulation in Scilab Xcos to get an idea on how to simulate pulse width modulation. One thing I came across is that there are two pulse width modulation PWM blocks, one from Scilab and one from the XCPL toolbox. However, this says just PWM, but when clicking on it, or just pointing at it, it says CCP underscore PWM. Well, the underscore is just a character. What's more interesting is CCP, which stands for Capture Compare, and this stands for Space Vector Modulation. Space Vector. And they are both used to drive anything, so you don't have, so using both is not really necessary, or actually is no use. So this one has the Scilab one, this one has the Scilab and XCPL one, and I'm going to remove this one. As a result, I'm shifting this one on. We'll save this as version 2 Xcos, and yes, XCPL version 2, I'm fine, save. So with that I'm going to actually run simulation, see what happens. If anything. Problem in port size or type. Oh, how nice. So I guess that this will not work. Let me do it something different then, because that message alone is not telling me anything. Is it this problem, or is this the problem? Let me do it this way. I'm going to replace this by the PWM. So this one is out. Can I just copy? I can. And yes, I do need this one as well. Oh, this is not funny. Okay, so I need to go here. Then I need interface. Somehow interface. And then I need PWM. And then this interface is no good. Going here, going there, going there. And then I have basically the same setup, but I need a motor in between. And this is basically the same setup as here, so I don't know exactly how to deal with it, but let's say components, actuator, DC motor again, and there I come back in the same place as I used to be. Something is not completely right in my reasoning. Let's get back. But before getting back to the old situation, let's run the simulation again and see if I get the same error again, which I clearly don't. That said, let me quit all scopes that are running. All are gone, and let me run again. So all are blank, effectively blank. But at least it runs. Scope 1, at least I think this is number 1. Yes, scope 1. Scope 2 and scope M, I think. Yes. Alright. That said, this is, as you can see from here, actually a pre-actuator, and this is a DC motor. Now in the real circuit I of course have here no motor, but here I want to have a motor. So somehow I need to do this. Question is how? I do need some rotational stuff, which is a sensor, and yeah, I do have a sensor, and this is such a sensor actually. So, and I know I had this before, so let me put this here, this one here, connecting. I know, but I need to do this. Select them away for a moment. This one is going here. This one is going here. So what I need now is this connection, with of course the question, how do I do that? And I don't like this happening once again. Component is out of the question. Sources, I need from triangle to square. Do I have that here? A source. I don't think so. A sensor I just used here, but this is neither. This is a source. do I need from electrical or blocks? Let me just look for it. And this looks like it, but not really the way I intend. But it has at least something. So by lack of, let me use this. Can I use it? But this one has one as well. So I guess I should put a ground on here. So let me take one. Just copy. There you go. And now something else to connect it. I don't know yet how. We'll find out, but this is the way I think it should be. So I have tried out a number of things, and those include finding a solution for connecting this motor, DC motor, and solution is a switch, which is I hope it opens. Yes, it is an ideal opening switch. So standard, it is closed, which is good. Then the XCPL space vector modulation, space vector pulse width modulation to be correct, continued giving an error that something was not connected correctly, etc. I did not find what it could be as a solution, so I removed it, unfortunately, because I love to know how it should be. And I put the CCP pulse width modulation, which is the capture compare, in, and decided to put another scope, etc. in between, to see if either a pulse or a constant value would be nice to go for. However, as the simulation will show, this is M2 and it shows complete blank, while as you can see it is directly after the pulse width modulation module. Then going to M, exactly the same. So the motor is not being driven since the speed is absolutely zero. Scope 2, which is this one, is not absolutely zero but has a constant, which is surprisingly given that this is not a constant either. However, this is a constant, so maybe this is influencing each other, although in a former simulation there was a difference. So whatever I have done wrong by now, I don't know, probably by just simply using the pulse width modulation in a wrong way, but I'm still looking for a correct thing there. Then finally scope 1, having the same idea as scope 2, and there's no difference in between, while they are clearly in a different, well, they are not really in a different spot. The only difference is there's diode, e.g. LED, and a resistor in between. So I might connect it somewhere here, but that will give the same 0 result as here, I suppose. In order to know for sure, let me close these scope outputs and then put it here. See what that brings. So remove this one. There you go. And this one should be nicer. So let me see what this gives. And by the way, you may have noticed, for simplicity's sake, I have put this to the ground, which may actually be the cause of this being 0, now that I think of it. So if I remove this and put it here, so now I expect a constant voltage which was 3 volts on here, and I expect something on here. Let me just see. Let me see what it comes off. Well, M2 is nothing, no surprise there. M here is a surprise, because it gets input from this, and this is a closed circuit, I think, and it gets 3 volts. Then scope 2, no change. Scope 1, no change. Okay, this is for now the end of the simulations. Let me rename this to 4. Xcos, yes. Go. Which is wrong, by the way. This is not the correct place. But anyway, I'll have to refocus, and we'll go back to my original real-life circuit. So back to reality. Right now, in this part of the circuit, which is at the moment not connected to the pulse width modulation feed, which is on this part, I can control the speed of this motor and propeller by simply switching or turning, better said, this pot meter. And there is the question if this motor is indeed pulse width modulation. Using a pulse width modulation controller from fischertechnik as well, I can control that motor. But looking at all the wires here, which is a bit messy, This is voltage, 5 volts voltage. This is also voltage. This is connecting it to the plus. So it's not getting its voltage here, from here, it's bringing it here, from here to here. Then voltage from here to the rest of the circuit, and this one is getting its voltage for the motor. Looking at this wire, it is getting it from seemingly nowhere. Oh yes, this is going to the potmeter, but this one is getting it out of the op amp, the operational amplifier. So what would the result be if I change this and I put it on this one? Again, back to it. So let me now, for testing purpose, remove or disconnect the voltage from the amplifier. And then, with everything more or less connected, like this. And yes, nothing is happening now. So this one is going to here. But there's nothing now going towards the power. So I will change that. And move it from here to, let's say, here. It does run, but does it run on the pulse modulation or on the power? So let me remove the power, and that says enough. Although, no, it doesn't say enough, because let me start the pulse width program, which is started with the value 1024. But it doesn't do anything until I feed it with the power. Alright, so let me change it to 512. And still nothing, and just power whenever I plug the constant power in. So I need to rethink. So to completely test it, I have taken a power controller which is pulse width modulated. It has a constant voltage of 9 volts. So if this is pulse width modulated, then hooking up, I should be able to control the speed by turning the knob. So I think this is kind of proof enough. that this is pulse width modulated. And this is the other direction. But it's 9 volts. And off again. So the question remains, why does the motor not respond on pulse width modulation of the Raspberry Pi? And my suspicion is that it is simply not the correct voltage, and losing the pulse width modulation, although if you can hear this, there's not as much difference. A little bit, but not enough to say, alright, this is pulse width modulated. So again, power off, and only with the very meager voltage of the pulse width modulation it won't work. So now the question is, how do I regulate the voltage of the pulse width modulation, and I think I need a potmeter again to do that. So let me change the circuit just for that. And I do think, alright, let me put this Oh, this is interesting. It's not shutting off now. Because, yeah, of course it's not shutting off, because it's not controlled anymore by it. So I should check it off this way. And then this should be going here, and let's see how this works. This is coming back. Is this not going anymore via the, this is here. So taking this off, this should be here. And now the power doesn't do anything anymore. So I need to reconstruct everything. And I think that is a nice follow-up for next time. Leaving out the amplifier, but combining this voltage with this pulse width modulation, and how that's going to work out. So thank you for watching, and once again, if you like my videos and haven't subscribed yet, please subscribe. If you like my videos, please consider advertisements between the video segments, and or see my website, which is listed under this video, to another way of supporting my blog. And this is to be continued.